right, let's go over number 2. In one city, 26% of all glass bottles distributed will be recycled each year. A city uses 275,000 pounds of glass bottles. After recycling, the amount of glass bottles in pounds still in use after t years is given by this function. N of t equals 275,000 times 0.26 raised to the tth power. So this is an exponential function, and we talked about how to take the derivative of an exponential function, d dx, of, let's say, a to the x power is equal to what? Natural log of a, natural log of a times that a to the x, right? So this is from section 2.6, part 2. And this was actually the very first lesson that we did since we went remote instruction, right after spring break. So it's been a while, but do remember we learned about how to find the derivative of an exponential function that had a base other than e. All right, so let's go ahead and do this, number 2. Find n of 5. Now that one doesn't have anything to do with calculus. All we need to do is just plug in 5 into that given function then. Okay, so 275,000 times 0.26 raised to the 5th power. Okay. All right, let me open up, oopsies. I'm going to open up a scientific calculator up here. Desmos scientific calculator. Here it is. So the equation was what? 275. Oopsies. 75,000 times 0.26 raised to the, there's something wrong with this buttons on my iPad. To the 5th power, right? So the answer is, what's that? Oh no, I don't want a fraction. The answer is 326.74 pounds. So after 5 years, that much glass bottles are still in use. Okay, so let's write that down. So this one, A, wasn't calculus problem. It was just really plugging in a value into the exponential function. And this one is actually the SLO problem that I need to give to collect data on your learning this year. So I think this looks just a little different than the other type of problems that I picked. But I got to give you this one problem so that I can collect data on your learning in Math 261. So SLO problem that you will have a similar one on your final exam. Okay, now we're doing calculus. They want you to find n prime of t. So find the derivative of the function. So that 275,000 is just constant, so just I'm going to pull that out. But what is the derivative of, with respect to t, of what? 0.26 raised to the tth power. And this is where we're going to use that rule from section 2.6. So 275,000 patiently waiting. Now we're going to multiply this by what? First, you need to write the natural log of the base, which is 0.26. So you need the natural log of 0.26, and we multiply this by the original expression, 0.26 to the tth power. Now, sometimes, remember, we have to use a chain rule to find the derivative of the exponent, but derivative of t is just going to be 1, so this is enough. This is your n prime of t. All right. Now let's go ahead and use this function to answer part C. They want you to find n prime of 5. So plug in 5 into that function that we just found above. 275,000 times a natural log of 0.26 times 0.26 raised to the 5th power. And I gotta go back to my scientific calculator. Let's see if I can remember this. Calculator. All right, so that was 275,000 times natural log. Oh, hello. Can you give me natural log? Oh yes, natural log of 0.26, right? 0.26, close parenthesis, times 0.26 raised to the, what power? Fifth power. And if I hit enter or they gave me the answer is negative. Okay, so we should talk about this answer, I think, on part D. So it is negative 440.14 rounded up to 14. And this one was what? The derivative function, right? So we found the rate of change. The rate of change is negative 440.14 pounds per year. So we're done with C, and what's the last part? Part D, they want you to interpret the meaning of this. This is the rate of change at year 5. So go ahead and say this is the approximate. This is the approximate increase or decrease? Decrease, right? Because it's negative. The approximate decrease in number of bottles still in use from year what? Year 5 to year 6. That's it. So that is how you do number 2, and just gotta kind of give you something like this on your final exam as an SLO problem for this class. And I just wanted to kind of give you a practice one before you do that. But if you you may want to review this part, how to find, how to find the derivative of an exponential expression that has base other than e. Okay, all right.